In this video, I will show you how to solve exponential equations when the bases can be made into the same number. It will be useful to consult an exponent table for some of these problems if needed. So, for example, 36 and 6 can both be written as the same base because how can I write 36 as a base 6 expression? 6 squared, right? So I can just write 36 as 6 squared. And then you take that x plus 1 and just put it in parentheses like this. Okay, so I've got 6 to the x plus 6 power. If the bases are equal, the exponents must be equal. So I am going to go ahead and distribute at the same time as I rewrite the next step. So this will be 2x plus 2 is equal to x plus 6. And now suddenly we're back in Algebra 1 class. Subtract x from both sides. That's x plus 2 is equal to 6. Subtract 2 from both sides. And x is equal to 4. So on this problem, the key is understanding that 1/2 can be written as 2 to a certain power. What power am I thinking of? Negative 1. All right. Let the record reflect that Coop is dominating this lesson. So go ahead and just put the x next to the negative 1. So we have 2 to the negative 1x power. 64 can be written as 2 to a power. I think it just goes off of the chart that you have, but you can see it on my version. All right. 2 to the 6th power is going to be 64. Mr. Burton, will we have that on our chart for the test? Yes. So this will be 2 to the, what did I say, 6th power? And then, of course, we have the 1/2 sitting there. So that means we have 2 to the negative x is equal to 2 to the 3rd power. If the bases are equal, the exponents must be equal. So negative x is going to equal 3. Which means x is equal to 3. Negative 3. Okay, for number 3, the key is going to be to, well, maybe y'all can tell me. Any guesses what I'm going to have to do to get that x out of there?
2 to the 3rd equals x.
Awesome, Ansley. Shout out to Ansley. Ansley said, let's rewrite this in that other form, the exponential form. So let's start with the base. All right, the base is 2, so I just bring that down. The x and the 3 are going to change sides when we go to exponential form. The 3 becomes the exponent, and the x is over there by itself. So this is the answer, or of course we could just write 8. X is equal to 8. So on problem number 4, we have a little Algebra 1 to do first. What do you think will be the first 2 steps I'm about to do, Algebra 1 style?
Subtract 6.
Subtract 6, and then divide by 2. Subtract 6, divide by 2. So if I subtract 6, that will give me 2 log of 5x is equal to 12. All right, that was subtracting 6 from both sides. If I divide by 2 on both sides, and I think I'll just go ahead and show it. Let me not be lazy. Dividing by 2 on both sides gives me log of 5x is equal to 6. All right, so that's the end of the Algebra 1 stuff. What's it time to do now?
5 to the 6.
That's close. Okay. Right. All right. That was Garvey over there jumping in on that one. The invisible base is 10. All right. This is log base 10. Maybe I'll just write it in for emphasis. All right. When there's no base showing, that's a base 10. So when we have to rewrite this in exponent form, this will be 10 to the 6th power is equal to 5x. We'll just leave it as 10 to the 6th power. Well, you know what? I'll show it both ways. So like you said, in the end, we need to divide both sides by 5. Maybe you hadn't said that already, but that's what you do. So some might write this as your final answer. 10 to the 6th power over 5 is equal to x. Okay? but understand this, 10 to a power. The 6 tells me how many zeros there will be. 1, 2, 3, 4, 5, 6 zeros. Okay? So, I mean, I would have accepted this as your answer. Okay, but for this particular problem, it wouldn't be hard with a 4-function calculator to go on and get the answer. So what is a million, divided by 5? 250,000?
No, 200,000.
200,000. Okay, these two are the same thing. All right, let's do problem number 5. All right, tell me the first step, anybody. Exponent form. 3 to the 4th power equals x squared minus 1. All right, there's no algebra 1 stuff you can do. You have to go straight to exponent form. So 3 to the 4th power, Zach.
Yeah.
Let me see those eyes. Lean the other way
Okay.
so I can see your eyes while we're doing this. So 3 to the 4th power, that's 81. So I've got 81 is equal to x squared minus 1. If I add 1 to both sides, that's going to be 82 is equal to x squared. If I take the square root of both sides, that's going to give me x is equal to plus or minus the square root of 82. That can't be simplified. Okay, so I'm just looking back to see if either of these would be extraneous if I plugged it back in. Why is, even the negative 1 will be okay for this particular problem. How do you know that at a glance, really? Because it's being squared in there. So if I took the negative radical 82 and put it in, the squaring would make it positive. So then minus 1 is still going to be positive, so it's okay. All right, so you could just leave your answer like this. X is equal to plus or minus radical 82. Okay, so on number 6, we're going to have to use the product property of logarithms before we begin. Remember the product property said, for example, if I had the log base 4 of A plus the log base 4 of B, I can condense that down to a single log of A times B. Right? That's the product rule. So that's what we're about to do right now. We're going to condense this sum down to a single log of a product. So this would be, well, on the left side, it'll still be log base 4 of x. But on the right-hand side, we'll have log base 4 of, and we have to do 3 times x minus 2. What do you think I'm going to do with this 3 times x minus 2 business? Distribute. Okay, Ben Rockaway, good job. So that's going to be 3x minus 6. Now, if the log and the base is equal, if I have log base 4 of something equals log base 4 of something, the stuff inside must be equal. That's called the argument. On the left-hand side, x is the argument of the function. On the right-hand side, 3x minus 6 is the argument of the function. So from now on, I'm just going to say the arguments must be equal. So that means x must equal 3x minus 6. Okay, so I would subtract 3x from both sides. We're back in Algebra 1 again. So that's going to be negative 2x is equal to negative 6. And then if we divide both sides by negative 2, we're going to get x is equal to positive 3. Is this extraneous, or is this okay? It's okay. I'm looking back at the original problem to make sure I don't get a negative number when I plug it in. All right, 3 minus 2 is positive 1, so that's fine. All right, number 7, base E. Now, if I were less educated than I am, I would write, as I try to write this in log form, I would write log base E And then I would switch these two parts of the expression around. So I'd have log base e of 6 is equal to 4 minus 3x. But a class as educated as you all are know what I'm doing wrong. What should I have done? Natural log. We don't write log base e. That's silly. That's ludicrous. We write natural log 6 is equal to 4 minus 3x. All right? And we just leave it like that. So we just do our two algebra 1 steps. So let's subtract 4 from both sides. So that's natural log 6 minus 4 is equal to negative 3x. And then we will divide both sides by negative 3. Okay, so our final answer will be x is equal to natural log 6 minus 4 over negative 3. So I don't think we will have a calculator for our test on this. So that's why we would leave our answer like this. If you did have a calculator and you were asked for a decimal approximation, of course you could type this into your calculator. I'm going to do that one time just to make sure we're all comfortable with how you could do that. But otherwise, that would be the final answer. So,
0.736.
Boom. Who was that?
Me.
Don't you want to say your name?
Oh, Hudson Curry.
Okay, Hudson. Looking a little different today. Okay, so this is how you could put it all in your calculator. So 0, whoops, what was it, 0.73? 6. Give me one more number.
0.
0, okay. All right, so if you had a calculator, then you could give a decimal approximation. Okay, last one. This one, all we can really do is rewrite this in log form. So how would I do that? Just tell me what to write.
Log base 4
Right? And as far as if you don't have a calculator, that's all you could possibly do. So this would be the answer if you don't have a calculator. If you're not allowed to use a calculator, this is the answer. Now, if you do have a calculator and you're asked to give me a decimal, you might have to write it in, you might have to use the change of base formula, depending on what style of calculator you have. So understand that the change of base formula says this is the same as log 13 divided by log 4. All right? So if you have a TI Inspire, you could probably just type it in without using the change of base formula. Or if you have a TI 36X Pro, you can type it in the way it was. But if you have a TI 84, you might have to do the change of base formula. You can still do it in different ways. Anyway, you know what calculator you have, so do whatever you do. But anyway, if you do have to do the change of base formula, here it is. Okay, so what was it? Log 13 over log 4. So I could do log 13 over log 4. Okay, 1.8502. So that would be the decimal approximation.
Okay.
All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.